Okay, then we shall start. Okay. Now, so the four-cylinder, four-stroke petrol engine, he says, so I'll just be writing the given data, whatever is being given. So engine configuration is what? It is four-stroke, four-cylinder. So just write this. It is four-stroke, four-cylinder. Next, has a bore of 60 mm and a stroke of 90 mm, he says. So if I take one particular cylinder of such arrangement, so what is the bore? Bore is given as 60 mm and the stroke is 90 mm. So 60 into 10 to the power of minus 3, whereas L is 90 into 10 to the power of minus 3. Okay. Next, it rated speed is 2800 rpm, so n value is given as 2800. Now it is tested at this speed against the brake, which has a torque arm of 0.37 meters. The net brake load is 160 newtons. So torque arm in the sense, so while calculating your stuff, so how do you calculate BP, by the way? How do you calculate BP? It is 2 pi nt by 60, isn't it? So how do you calculate the torque? It is W minus S into capital D plus small d divided by 2. So this is nothing but the radius, isn't it? This is nothing but the radius, and it is also called as the torque arm. Okay, so this is also called as the torque arm. So that particular parameter he has given. So that is why I'll be taking it as capital D plus small d divided by 2, which is nothing but the torque arm. How much is the value of the torque arm? It is 0.37 meters. So that is the value of torque arm he has given. The net load on the brake drum. What is the net load on the brake drum? What is the net load on the brake drum? It is W minus S, correct? So W minus S is the net load on the brake drum. Okay, so this is how much net load on the brake drum is 160 newtons. 160 newtons. So the fuel consumption he has given, the mass flow rate of fuel, how much it is? It is 8.966 liters per hour. Be careful about the units. He has given in liters per hour. Specific gravity of the petrol he has given. So I would just write neatly that specific gravity of petrol. How much he has given? He has given it as 0.74. Okay. It has a lower calorific value, so CV value is being given. It is 44100 kilojoules per kg. A Mohs test is carried out. Now the Mohs test parameters would be given. So I'll be taking one by one. Yeah, just shift to now the Mohs test parameters. The Mohs test parameters. So just write it down. Is carried out the cylinders cutting off of the order. So see, in the Mohs test, what we'll be doing, we'll be first cutting off the first cylinder. Next, we'll be cutting off the second cylinder. Next, we will be cutting off the third cylinder. Next, we'll be cutting off the fourth cylinder. So while cutting off so on, so what are the different parameters you will get? So after cutting off the first cylinder, after cutting off the first cylinder, the brake load he says, okay, brake load he has given. So net load on brake drum, that is nothing but W minus S of 1 is 110 newtons. So this is when the first cylinder is being cut off. Okay, similarly, when the second cylinder is being cut off, that you have to take, just move this still more down. Okay. Okay. Now, when the second cylinder is being cut off, W minus S of 2 would be how much? Just read the problem. It is 107 Newton. Similarly, when the third cylinder is being cut off, the net load on the brake drum would be how much? 104 Newton. Similarly, when the fourth cylinder is being cut off, the net load on the brake drum would be how much? It is again 110 Newtons. Got these parameters, everyone? Okay, what we need to find in this particular problem? So we need to find, the first one is the brake power. We need to find what is the brake power. Second one, we need to find what is indicated power. We need to find what is indicated power. Okay, third one, brake mean pressure. That you have to find out, brake mean effective pressure. Fourth one, brake thermal efficiency you have to find out. So the brake thermal efficiency you have to find out. And the fifth one is the mechanical efficiency you have to find out. So this is the problem. Getting it? Shall we start the solution for this? Shall we start the solution, guys?
Yes, sir.
Okay. First, find out the brake power. So we need torque. Torque is W minus S. That is given as how much? W minus S is given as 160 newtons, correct? So it is 160 there. So just write 160 cross torque arm. Torque arm will remain same for everything. So 0.37 is the torque arm. So 0.37. So now what is the brake power? Not brake power. First we will get the torque, isn't it? What is the torque? In newtons meter. Once you got the torque, you will calculate the brake power, 2 pi nt by 60. So it is 2 pi n as 2800 cross the torque, whatever you have calculated, divided by 60. So whatever you get, and this should be in watts. So the first thing what you are calculating is the brake power. Next one, the torque. How much is the value left?
17.35 kilowatt.
17. Okay, directly 17.
Torque is 59.2, sir.
59.2.
9.2.
Okay. 59.2 Newton meters. So this is 17.35 kilowatts. Okay, very good. So remember, I would just remember. So this is brake power when all 4 cylinders are running. All 4 cylinders are running. So this is the brake power when all 4 cylinders are running. So second thing what you have to find out is, indicated power. So indicated power. So since this is a problem on Morse test, so Morse test indicated power is given by like this. IP is equal to, please observe the formula very carefully. Okay. IP is equals to BP minus BP1. Okay. Or before to that, I can just write IP1 minus plus IP2 plus IP3 plus IP4. Now, what is this IP1, IP2, IP3, IP4?
Indicated power at each.
Exactly. So how will you calculate? It is BP minus BP1 for IP1 it is. Now for IP2 it is BP minus BP2. Now for IP3 it is BP minus BP3. Now for IP4 it is BP minus BP4. Okay. I would just rearrange this stuff. So I would take this BP values here. BP, 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 BP. Can I write it as 4 times of BP? Okay. Minus of all this BP1 values. BP1 plus BP2 plus BP3 plus BP4. So this is how I would calculate my indicator power, and I would mark this as equation number 1. Got it, everyone?
Yes, sir.
Everyone? Now I should calculate the values of BP1. I should calculate the values of BP2, BP3, and BP4. ಏನಪ್ಪ ಇವು BP1, BP2, BP3, BP4? What are this? What are these?
Brake power at each cylinder.
This is the brake power. Okay, I would just write it
Brake
here.
power of individual.
So it is the brake power when first cylinder is cut off. Okay. Similarly, for all this, BP1 is when the brake power is for the first cylinder when it is cut off. Similarly, when you cut off the second cylinder, when you cut off the second cylinder, it is BP2. When you cut off this third cylinder, it is BP3. And when you cut off the fourth cylinder, it is BP4. Okay, I would just change all this. When the second cylinder you cut off, whatever the brake power you get, that is BP2. When the third cylinder you cut off, whatever the brake power you get, that is BP3. And similarly, when the fourth cylinder you cut off, whatever the brake power you get, that is BP4. Okay. Now, how do you calculate this BP1, BP2, BP3, and so on? So it is simple. It is BP1 is equals to 2 pi n would be common, speed would be common for all the things. Only torque would change divided by 60. Now, how would you calculate? How would you calculate the T1? How would you calculate the T1?
W minus is 1 into 0.37.
Very good, very good. So T1, I would just wait. Okay. T1 is nothing but W minus S of 1 into 0.37. That is capital D plus small d divided by, I'll just directly write it as 0.37. Just substitute the value, guys, and give me the value of T1 and similarly B1.
11.93 kilowatt.
It is 11.93 kilowatt. Now, go for BP1 calculation. So it is 2 pi, n number ಏನದಲ್ಲ 2800 divided by 60 cross. Oh, you have given directly the value of BP1.
Yeah, sir.
Okay, so give me the value of torque. This is 11.93 kilowatt. How much is the value of torque?
40.7.
40.7 Newton meters. Similarly, you go on calculating for everything. Next, calculate T2, W minus S of 2 into 0.37. So, give me the value. Similarly, BP2, you just calculate. It is 2 pi N T2 divided by 60. So, it is 2 pi 2800 cross. This is 40.7. divided by 60. So what value we get? Just write it here. Similarly, T3, W minus S of 3 cross 0.37. Similarly, T4, W minus S of 4 cross 0.37. Next, if you go for BP3, it is 2 pi N T3 divided by 60. BP4, 2 pi N T4 divided by 60. It is 2 pi 2800 cross the torque value divided by 60. Next, it is 2 pi cross 2800 cross the torque value divided by 60. Ah. Anyone just give me all the values T1, T2, T3, T4 and BP1, BP2, BP3, BP4 once you have calculated. Okay. Or else I will just write the textbook values. So just check, cross verify it. Okay. So this is 39.6 Newton meters and BP2 is 11.6 kilowatt and T3 is 38.48 Newton meters and similarly BP3 is 11.28 kilowatt. Since this one is same, this will again get the same. It will be 40.7 here Newton meters and BP4 is how much? BP4 is 11.93 kilowatt. Just check the values. If you get the same values, please raise your hands.
Sir, IP is 22.65 kilowatt.
Oh, wonderful, wonderful, wonderful. So after that, you can just calculate the value of IP. So IP is 4 times of BP when the all 4 cylinders are running, minus of BP1 plus BP2 plus BP3 plus BP4. So 4 times of BP is what? BP is 17.35 minus of BP1 was 11.93 plus 11.6 plus 11.28 plus 11.93 again. So the IP value, whatever you get, it is 22.66 kilowatt. Got it, everyone? If you get the same value of IP, you can raise your hands. Thereby, you come to know you have solved it. Okay. Very good. Next, go on with the further calculations. What are further calculations? So we have done with BP. IP is done. Next, brake mean effective pressure. So how do you calculate brake mean effective pressure, guys? The third one. Brake mean effective pressure. So how do you calculate brake mean effective pressure?
BP into 60 into 2 divided by ln.
Correct. So if we calculate IP, it is plan divided by 60 cross 2 for the 4-stroke. Now, if you replace IP with BP, so whatever mean effective pressure was there, that would turn into brake mean effective pressure ln divided by 60 cross 2. So substitute all the things there. And so it is 17.35 into 10 to the power of 3, that is equals to brake mean effective pressure. That is the thing you have to find it out, cross ln. Ln in the sense L is 0.09, area is pi by 4, 0.06 whole square, cross speed is 2800. Okay, and cross 4. Remember to multiply it by 4 divided by 60 cross 2. So if you do so, the brake mean effective pressure would be around 7.3 bar.
Sir, why sir into 4?
Number of cylinders, 4.
You said for BP only for IP.
So you're not calculating BP, no, here. You're not using, so whether I have done 4 for this, in the BP ಮಾಡಿದ್ವಲ್ಲ ನಾನು ಇಲ್ಲಿ ಏನಾದರೂ 4 ಮಾಡಿದ್ನಾ ಇಲ್ಲ ತಾನೆ. So now we are using the indicated power formula, in the sense you have to do cross 4 here. So when you do cross 4, then it has a complete meaning of 4-stroke 4-cylinder. Okay.
Sir, can you scroll a bit up, sir?
Okay.
Done, sir.
Next ಇಂದು ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಸ್ವಲ್ಪ tedious ಇದೆ. We require again the concepts from the FM. Okay, we'll do it. Okay, so for that I want everyone to be free, everyone to be solved by this. Once you have completed everything, we will solve that particular thing. Okay. So just intimate me once you have done all this. Shall we start? Shall we move on?
No, sir.
Okay. Calculate. No issue.
Sir,
Yes, Anish.
sir, why we did into 4 there? Because yesterday you said the BP does not affect number
BP
of.
does not affect while you are calculating the value of the brake power, which is this. Here it does not affect anything. But while you are calculating the mean effective pressure, you are using the formula for indicated power, isn't it? Then definitely have to take it 4 into 4 there.
Sir, then yesterday, last class you said we don't have to consider 4 number of
Last
seconds.
problem we have considered or not?
Didn't consider, sir. 4.
Yes,
Didn't
sir.
consider. What is that problem number? Just give me. I will check. ಯಾವ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಅದು
Or if
here you have to take it as by 4 into 4. I mean to say into 4. Okay, this is into 4. I think the value would change now, right?
Yeah.
Okay, then this is a wrong value. So you have to take into 4 there. Okay, clear ಆಯ್ತಾ?
Yes, sir.
Shall we move on? Shall we move on? Okay. Now, next what you have to find out is the brake thermal efficiency. So efficiency, brake thermal. So for this particular brake thermal efficiency, how do you calculate? It is BP divided by MF dot cross CV. Now, what is the value of BP that you have got? 17.35 kilowatt. Now, MF what he has given? 2.966 liters per ಕೊಟ್ಟಿದ್ರಲ್ಲ ಅದು MF 8.966 liters per hour. Okay, so it is absurd unit. ನಮಗೆ ಮೀಟರ್ ಕ್ಯೂಬ್ ಅಲ್ಲಿ ಇಲ್ಲ, kg ಅಲ್ಲಿ ಇಲ್ಲ, something liter ಅಲ್ಲಿ ಇದೆ. We will see how to do it. Okay, next, what is the value of CV? CV is 44,100 kilojoules per kg. Okay. So I told you, all of you carefully observe this. I told you the numerator and the denominator while calculating the efficiency should be of the same units. So BP is of which unit?
Kilojoules per second.
Kilowatt.
Kilojoules per second is nothing but kilowatt. So even the MF dot into CV should also be in kilowatt or kilojoules per second. So for that, what you have to do, just check on the units. MF dot into CV. So MF is in what? MF is in something liters per hour, isn't it? Liters per hour. Nowhere possible. Not at all possible. Into CV. CV is what? Kilojoules per kg. Nothing can be done, isn't it? No cancellation, nothing. So what you have to do is, in this particular scenario, okay, so what I have to change this to, I will just mark it with a red now. What I have to change this to? Liters I have
Kilogram
to change
per
this
second.
to. What I
Kilogram.
have to change liters to? Liters to what I have to find, so that this cancels with kg.
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 Kg, isn't it? This liters have to be converted to kg. Now, what should be done this? Hover. So that at the end result, I can get kilojoules per second.
Seconds.
Second.
1600.
Second. So this is the change I require in the form of units. So for that, okay, I would help you to calculate, I would help you to convert liters to kgs. How to convert liters to kgs, I would help you. Now, you know how to be converted hours to second, isn't it? You know that very well, I guess.
3600.
Yes, sir.
Exactly. So what we'll be doing is we'll be taking MF dot nav. So I would be taking MF dot. Okay. That is in what? That is in 8.966 liters per hour. So I can convert this to seconds now. 8.966. Okay. I would convert it into liters per hour. It's not hour. Per second if I divide this by 3600. Am I right? Now it is in liters per second. Okay? Yes or no, man?
Yes.
Yes, sir.
Okay. Now, so what is 1 meter cube? In 1 meter cube, how many liters would be present? 1 meter cube is equals to how many liters? I already taught you in the class.
1000.
1.
Exactly. Very good. So 1 meter cube is how much? 1000 liters. Similarly, if I transpolate this, 1 liter is equals to 10 to the power of minus 3 meter cube. Am I right? Just transferring 1000 to the either side. Correct? Yes or no?
Yes.
Okay, then. So if I substitute here 8.966 divided by 3600, okay, into, so what is 1 liter?
10 power minus 3 meter cube.
1 liter is, so it is 10 to the power of minus 3. Now the whole thing is in meter cube per second. Okay. Got it? So this is volume per second. So it is nothing but your volume flow rate. What it is? It is volume flow rate. Now I have to convert volume flow rate to the mass flow rate. I have to convert volume flow rate to mass flow rate. What is the relationship between the volume and the mass? How these are interconnected?
Density.
Volume and mass.
Density.
Density.
Correct? Very good. So I can write it as mass flow rate by volume flow rate as density, right? So I would just keep this particular thing aside. Now I will move for specific gravity. What do you mean by specific gravity? It is the density of the fluid divided by density of water, correct? So from this, density of fluid is equal to what? Specific gravity cross density of water. Now what is density of water?
1000.
Exactly, it is 1000 kg per meter cube. Now, has he given the value of specific gravity in the question?
Yes, 0.74.
What is that value?
0.
0.74. Just substitute it here. 0.74 cross 1000. I hope the value is 730 or 740 kg per meter cube. This is the row of fluid. Okay. Got it? So if you know the row of fluid, okay, come back to here, this particular concept. If now I know the row of fluid, okay, now I know the volume flow rate. Can I calculate the mass flow rate? Yes or no?
Yes.
So just substitute. So here from this, here it implies the mass flow rate is equal to rho into the volume flow rate. So whatever you have observed here is, this is the volume flow rate. Even this is also a volume flow rate. Okay, volume flow rate he has given. We need to convert it into the mass flow rate.
Sir, can you show this page full?
Someone said something? Someone asked me something.
Sir, can you show this full page?
Okay, at a single stretch. Okay, something like this. Okay. So finally, what is the mass flow rate in kgs per second?
1.843 into 10 to the power minus 3.
How much?
1.843 into 10 to the power minus 3.
1.84 into 10 to the power of minus 3 kgs per second. Correct. Value is correct. Okay, got it. This is a pretty old problem, man. Okay, 2018 ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ backlog subject ಗೆ ಒಳ್ಳೆ ಸಗದಾಗಿದೆ problem ಇದು. Okay, so before you arrive this, you can come to a conclusion here. Okay, let us check for the units of this and this. Okay, see, mass flow rate is equals to density into volume flow rate. I said, what is the density units? What is the density units, guys?
kg per meter cube.
Kg per meter cube. Cross. What is volume flow rate unit? Volume flow rate unit.
Meter cube per second.
Meter cube per second. So what happens here? Meter cube goes away, and the remaining whatever is there, that would be in kgs per second. That is what I have written here. Okay. So this is how you convert a volume flow rate into a mass flow rate, thereby arriving at kgs per second. Okay. Now, I think the problem is simple. We can go on with the substitution. Okay. So the efficiency breakthrough thermal is equal to what? Brake power. So how much is the brake power? 17.35 kilowatt divided by MF. You have just calculated 1.824 into 10 to the power of minus 3. Cross CV value was 44100. So whatever answer you get, so if you just it would be in percentage. If you just multiply this stuff with
21.38 percentage.
21.38 percentage, and that is the value. Okay. So anything else left to solve in this particular problem? Let us check once more.
Mechanical efficiency.
So brake mean effective pressure done. Your mechanical efficiency mod or the help beka. Fifth one, mechanical efficiency. So how to do this? It is BP divided by IP into 100. BP have just written it as 17.35. IP ಎಷ್ಟಿದೆ value?
22.65.
ಎಷ್ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರಲ್ಲ 22.65 into 100. So whatever value you get it in percentage.
76.6%.
How much is the value? 76.6%. Okay. So this is how you calculate stuff when there is a volume flow rate given. So you need to convert into the mass flow rate. This is the new concept that you have learned. And another new concept is usage of the Morse test to calculate your value of IP. Okay. Any doubts in this particular problem?
No, sir.
So I would give you the similar problem, which is much more easier than this. Okay. Will you try?
Yes, sir.
And I need answers within next class. Okay. I will just post the things now. So this is also a question on the Morse test, and it is very, very easy. Okay. Just try this. Just take a screenshot if possible. Okay, I would be checking randomly in the next class. So everyone should solve this and come for the next class. Okay. So we will end up, I will leave you 10 minutes early. So just mark your attendance in the Google Sheet and have a great time ahead. We'll meet up in the next class. Take care.
Sir. Thank you, sir. Sir.
Head of
ಸರ್ ನಂದು ಅಟೆಂಡೆನ್ಸ್ ನಿನ್ನೆ ಹೇಳಿದ್ರಲ್ಲ ಇವತ್ತು ನೆನಪು ಮಾಡಿ.
ಆಯ್ತಾನೆ ಒಂದೇ ನಿಮಿಷ ನಾನು ಚೆಕ್ ಮಾಡ್ತೇನೆ. ಲೈನಲ್ಲೇ.
ಹಾಂ.